Hello, pre-algebra. Mr. Lawrence here with your test review. Flipped lesson for Thursday, February 9th. I know you guys can do your best on the test, but make sure you're reviewing the materials. All right, first of all, we're going to start off with polygon. I think we're going to start off with an unusual one. Hold on one second here. I think I need to find me a decagon. Why? Because I like to say decagon. Hold on one second. Okay, I found where I placed my decagon, and of course that is the name. It is a decagon. How do I know it's a decagon? Because it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So it is a decagon. And the first thing I'm going to do is I'm going to figure out the total number of degrees. Total number of degrees. Okay, the easiest way I know to do that is to break it up into the number of triangles. I'm going to pick a vertex, say like this one here, and I'm going to draw diagonals to every other vertex that does not already have a line segment drawn to it. And I count how many triangles I have. All right, now those of you who are really good at this, you know that there's going to be 8 triangles. How do you know there's 8? Because there's always 2 less than a number of sides. So 1, 2, 3, 4, 5, 6, 7, 8. Sure enough, 8 triangles. Well, there are 8 triangles, and every triangle has 180 degrees. Therefore, if I multiply these numbers and get a 0, a 4, and a 14, I know that there's 1,440 degrees in my decagon. All right, now, could I figure out how big just one of the angles are? Let me get rid of these diagonals. They're in my way. All right. Well, I sure could. I know that I have 10 angles coming together. If I want to know how big angle X is right here, that's one of the 10. If it's a regular decagon, all the angles are the same, right? So I could just take measure of one angle. I would take the total number of degrees, total degrees, and divide by the number of angles. This only works when it's regular. Remember, regular means all angles and all sides are the same. If it's not regular, I have to do a little more. So the total number of degrees in this case is 1,440. There are 10 total angles, and that means that there are 144 degrees. X is 144. So I'll get rid of the X, and I'll put in 144 degrees. Now, what would the measure of an exterior angle be? Well, remember, the exterior angle is just this angle out here. Perhaps I'll call it Y. That's pretty cool. I didn't go back into right mode, but I still made a Y. Well, to find the measure of an exterior angle, measure of an exterior angle, I'm going to do 180 minus whatever X was. Why is that going to work? Because if you look, I have a half a circle right here. Half a circle has 180 degrees. So I'll do 180, ooh, not 140, 180 minus 144, and I believe that'll be 36 degrees. All right, so that means Y equals 36 degrees. Now remember, there are exterior angles coming off all these sides. Kind of looks like a pinwheel, right? If I were to add up all the exterior angles, the polygon's regular, so they're all going to be 36. There's 10 of them. 10 times 36 is 360 degrees. And that is not a coincidence, because if you look at the shape, the pinwheel kind of shape of the exterior angles, it kind of looks circular. In fact, if I spun it really fast, it might look really circular. All right, so there is the decagon. You'll need to know how to do some other shapes, but that's how you do it for all of them. Follow those procedures. Okay, next type of problem. Let me see here. Let's determine if 2 rectangles are similar. Well, let's see here. Let's get this rectangle and this one here. And I'm going to tell you that this is 12 and this is 2 centimeters. And I'm going to tell you that this is 5, and this is 8 centimeters. I want to know if these polygons are similar. If they are, excuse me, I should be able to set up a proportion, and then when I do the multiplying part, the cross multiplying, I should get the same answer. So I'm going to write 12 over 2. And then I'm going to write 8 over 5. If they are equal to each other, you guys know this is review. If they are equal to each other, then the cross products will be equal to each other. Well, 12 times 5 is 60. 2 times 8 is 16. They do not equal each other. These polygons are not similar. All right. Okay, let's look at one more of those. I will give you 2 triangles, and you tell me if they're similar. Do it by setting up the proportions. Okay, and I'm going to make this 12 and that 4, and I'll make this 7, and I'll make this 21. Oops, 21. All right, go ahead and pause the video, and when you're done setting up your proportion and cross multiplying, you can check with me. If you're watching at this point, I'm assuming that you're ready to set your proportion. This time I'm going to go hypotenuse over hypotenuse, 12 over 21, and then horizontal leg over horizontal leg. And notice I was very consistent. I started on the left on both sides. Oh, pardon me, I'm fighting off a little cold here. All right, I'm going to cross multiply, and I'm going to get 84, I believe, right? Then I'll multiply this way, and I will get 84. And they are equal to each other, so these polygons are similar. Okay. Now I know you guys are used to doing problems with polygons where you have to find x. So let's look at one of those. There we go. And let's see, let's make this 10 inches, this 6 inches, and this 5 inches. And then let's say this is 8 inches, and we'll make this x. Okay. Now, you have to be careful here. I've given you more information than you need. So when you go to set up your proportion, well, I have the top, those two match up. So I can write a fraction, a ratio of 10 over 8. Now I'm trying to find this x. Well, I've got to match it up with the corresponding side in the other polygon. A hexagon to be specific, that would be this 5. I started with the left polygon in my numerator. That's the left. And this one's on the right. Well, when I go to do my other side of my proportion, I have to start on the left, so that would be the 5, and then put it over the one on the right. Okay. I'm going to cross multiply, get 10x. That's going to equal 40. Divide by 10, and x will equal 4. So s must equal 4 inches. All right. Some of you are noticing that 5, 10 is doubled, and 4 and 8. For double 4, you get 8. That's true if they're similar. Those ratios will hold true, but make sure you show your work or explain your answer. Don't just write down and then say, that's how I did it. All right, 2 more things to go over here. The first thing will be, hold on one second. Okay, the first thing will be parallel lines. And so let me get some parallel lines going here. Now, let me also say that if I don't cover something as thoroughly as you need it covered in this video, you're always welcome to go back and review the other videos from the past, right? Find them in the same place. The dates and titles of the lessons are usually there. Okay, I'm going to tell you that this angle here is 80 degrees, and this angle here is going to be 60 degrees, and I need you to find angles A, B, C, D, and F, or we'll call it E, sorry. All right, now some of you are going to look at this, and hopefully right off the bat you can see an upside down F, or maybe you see a backwards F. Uh-oh, hold on. Okay, we're okay. So here's an F, which means that 60 and the A are corresponding angles. I'll put 60 degrees in there. From there, you should be able to see the Z. A and B are alternate interior angles. B is 60. Now BC is easy because of the half circle. 180 minus 60 is 120. So therefore C is 120. Now, that doesn't affect D and E at all. Now, I can also, there are other ways I could have done it. I could have said, well, I see an F here. That would tell me that this one here is 80. But check it out, there's even an F here that uses D and doesn't use that middle part. I can like totally bypass that one. See that upside down backwards F? So D has to be 80. E is vertical. That means E and D are both 80. Okay? One more thing about this. What if you wanted to find angle F? Well, these three together make 180 degrees, right? So, I could add 60 and 80 and get 140. And therefore, 180 minus 140 would be 40 degrees. Okay, should be pretty good at those by now. All right, let's move on down and talk about the Pythagorean theorem. And remember, C is always the hypotenuse. C is the hypotenuse. The hypotenuse, the longest side of a right triangle. It is always found directly across from the right angle. Always. The first thing I would do when I have a Pythagorean theorem problem, I would go ahead and identify the hypotenuse. How do I do that? I go to the right angle, draw a line to the opposite side, and that is always C. Always. So, if I had a problem, I'll give you two problems to look at. Let's say we have this triangle and that one. Turn that one that way. Okay. Let's say that we knew this was 12 and this was 8, and we were looking for the height. And in this one over here, we are looking for that side, and this is 10 and that is 7. Again, in both problems, I'm going to do this. Find the hypotenuse. Once I do that, I can set up my equation. 12 squared. And that's going to equal x squared plus 8 squared. Okay, this should be total review. You guys should have mastered this by now. Over here, that's my hypotenuse. That's C. And then I go 10 squared plus 7 squared. On the left-hand side one, first thing I'm going to do is square everything. That I can. X squared, then I'm going to subtract 64. Looks like x squared is going to be 80. Then I need to take the square root of each side. And that that'll be a number very, very close to 9. It's going to be just under 9 and probably even round to 9. It actually comes out to be about 8.9. 8 and 9 tenths. Okay, I didn't give you any units, so the word would be units there. All right, on this one, I'm going to square everything, get 100, get 49, x squared. Now I'm not going to subtract anything because that's an addition problem. I'll just add them together. All right, now I'll take the square root of each side. That's how I undo the square. And I'm thinking that square root of 144 is 12. This is pretty close to 144. This is going to be a little bit more than 12, probably like a 12.2, I'm guessing. Well, let's see. I'll punch it in. And I got 12.2. Rounded, of course. All right, very good. Mr. Lawrence signing off under 15 minutes. Good night, everybody.